What's up, guys? Welcome back to Glow Electro. Today we are turning groceries into power plants. No hacks, just real chemistry doing its thing. And it's literally a very basic and cool science experiment. So, step one, what are the things we need? Here's the squad. We need a lemon, we need a potato for as a source of battery, right? And then we need these copper strips for passing the current through, or you can use a zinc nail, or you can use a copper coin, right? It's up to you, whichever you want to use. If you're using a zinc nail, use a copper coin with it, or else you can simply use copper strips, right? Now, to connect this with an LED, so you need an LED to see the output of what we did, or a bulb. You can choose any one of it. Then this whole thing, you're going to connect it with wires, so you can use alligator clips or normal wires. Alligator clips, why are they called alligator clips? Is because of how they look. They have a mouth like this. They literally look like alligator teeth, right? So that's the reason why it's called an alligator clip, right? So that's all the things that we need. That's it. No crazy lab setup. I'm gonna link all these things in the description. Amazon links in the description, so do check it out, or you can get it from local. Totally up to you. Coming to the steps, really easy steps. It's not so hard. So first of all, we are going to prepare the fruit. Prepare the fruit means we're not gonna make a salad out of it. We're just gonna squeeze it. So either squeeze it or roll it on a hard surface. Why are we going to roll it on a hard surface? Is because we want it to become juicy. We don't want it to be rigid or something. So you are gonna roll it and it is going to release the juices from the walls. That juice is called conductive juice, which is an electrolyte. So it's a technical word. It's called electrolyte. Now, electrolyte is so important. I'll tell you why and how we're going to use it. Next step, you are going to insert our electrodes. What are our electrodes? I just showed you, right? The copper strips or the zinc nail or your copper coin. Those are your electrodes. Now, very important. If these two metals touch, it's game over. No electricity, right? So you are going to make sure they are at least an inch apart from each other, right? At least an inch apart from each other. All right, then you're gonna connect it, link it together with your alligator clips. Use alligator clips or an insulated wire, like how we did in our, this is an insulated wire and this is an alligator clip. Use that. Final step, connect it with an LED, right? You're going to attach an LED, right? And that's how it's going to glow. Okay, so that's it. From 11, that's just normal grocery. And we're going to make such a special science experiment. Now, first, before checking the voltage, let's actually do this live. We are going to use Tinkercad website. The Tinkercad website, I'm going to put it in the description. Let's log in, students with class code. Okay, look at the steps. Students with class code. And then we're going to enter the class code. This is the class code, right? This is the current batch that is going on. And whatever circuits we do in the future, all those videos, I'm going to have them, all the circuits is going to be in this class, and you can refer from my circuits to make your circuits. Even I can watch your circuits. If there is an error, I'll make a comment on it and say, oh, change this or change that, right? Go to my class, login code. Everyone has their own specific login codes. I want you guys to put in the chat box whatever login code you want, because I'll give you that. So I actually made a whole entire video on how to make this whole thing on the Tinkercad thing. So do check that out. Go to my class. Okay, electronics, view class. Here you see all the activities. So in future, whatever activities I'm gonna add, you will see it here. We're gonna click this, lemon and battery, potato battery, new design circuit. So we need an LED and we need a bulb, right? And of course, our heroes, lemon. Oh, I just advanced it. And a potato. Potato, patata. Same thing. Okay, we're gonna attach it. Can you see? You can just attach it like this. Boom, done. Boom, done. Right? So be here. So here, I'm gonna tell you what is cathode and anode, positive and negative. The red one is always positive, black one is always negative. The bulb is not it's not polarized, it's unpolarized, right? So it has terminal one, terminal two. It doesn't have a certain charge on it. So you can either flip it or do anything and you can connect it. It's gonna be the same. LED has a charge. It's going to have anode and cathode. Anode is a longer leg if you observe. It's longer and it's the positive side. The cathode is a shorter leg and it is the negative leg of your LED, cathode and anode. We're going to connect it like this, anode in the positive, cathode at the negative. Let's click start simulation. This is the one where you can check how it's working. No light. Oh no, what did we do wrong? So basically, you are going to see the voltage is really less. What is the voltage? I made an entire video about voltage in the previous lesson, so you can check that out. Voltage is basically how much force is there in this lemon to light up the LED. You're going to use a multimeter to check the voltage. So in real life, you will use a multimeter like, and in Tinkercad, you are going to use, this is a multimeter that you can read it from. You can also add the multimeter from here. So I want you to I want you guys to add the multimeter and check it out, but I'm going to read it from here and we can make changes. Now here, what's happening is one lemon can only provide us 0.9 volts, which is really less. It's not even 1 volt. And a potato even more or less, which is 0.8 volts. And it's not enough. It's like someone giving so less efforts. Would you like it if someone gives less efforts? No, you wouldn't like them, right? So yeah, that's how it is. So we are gonna use 3, 4 lemons or potatoes to make it more fun. The more the potatoes, the more the voltage and power, right? So if voltage increases when you add things in series. Okay, series, remember the keyword. Because I'm gonna make another video of series in parallel. So connect them in all series, one beside the other, and it will increase the voltage. Um, for like 4 lemons, your voltage is around 3.7 volts. This one. And for potatoes, it is 3.3, which is less, right? Now, if it's less, it doesn't mean it's bad. I'm going to tell you why it's less than high. This whole concept of why this is having a high voltage and why this is having a less voltage is because of the acidity level. Your lemon is more acidic, which is greater acidity, which is around 2 pH, and your potato has around 6 pH of acidity in it, right? So which is the reason why it doesn't have that much voltage and it's because it's not so acidic, right? Now, the acidity level, of course, you cannot squeeze a lemon in your mouth, right? You're gonna be like, that's so sour, right? Now here with potatoes, see, it's not bad that it does not have that much voltage. It is actually good. I'll tell you why. Because of the longevity of your battery. Longevity means how long is it going to last, right? This is more acidic. It's like your toxic ex, which love bombs you in the starting. Kidding. I'm just kidding. Okay. So which is having a higher voltage, but it's gonna use up the entire voltage very quickly and it's just gonna die soon, right? It would not last long. Whereas potato is much stable. It's boring because it has less volts. It's gonna last much longer, right? Because it's steadier. It has lower voltage, so it's gonna last really long. So the battery will last long. Coming to our circuit, which was not working. Let's make it work. We're gonna increase the voltage. Let's start with the potato, the good boy. If to click stop simulation, LED, no, the potato. Let's give 100, right? It's blowing up. And for this one, 1,000. This is more acidic, right? So it can send out a lot of volts. I've put a lemon because at least lemon is much bigger. It can handle the voltage of it. You can also put an LED, it will still work, right? Even if it glows a little, it's legendary. Like let's suppose if I make it 100, it glows less. So it depends on how much voltage you are putting in, right? So that's the thing. You are for this now online, I've changed it like this, but when you're doing it actually, you can add more and more and more lemons to see the difference, right? This is literally how batteries work. I'm going to show you what is the concept that is going behind, what is the chemistry going behind this whole thing, right? What's happening is your lemon or the potato are having they are connected to zinc and copper coins, right? The lemon is not, the lemon or the potato is not making electricity. The real drama is happening between the zinc nail and the copper coin, right? So zinc is anode. It is the it is going to be having, you know, all those ions in it, and it's gonna be like, I'm unstable, bro, take my electrons. And copper is a good person and it's gonna be like, okay, cool, I'll take them, right? So the electrons start moving, go here, and because of the movement, it generates current. We have read about this whole current thing in the previous class. So it generates current, and because of the pressure, it's the voltage that's providing pressure, and it's lighting up. So when you put an LED in between, boom, it's gonna light up, right? What is electrolyte? The juices that we squeeze the lemon for. Now, this electrolyte is not the main person doing anything, it's the middleman, but it is also important because this is the one allowing the flow of ions, right? If it's not like making, it's not, if it, you do not have a juice, it will not move around, right? So that is the reason why we need electrolyte. It's going to be like a medium to flow the ions. That's literally how batteries work. Not only this, but your all types of batteries. Say, for example, the 9V battery. Let's put it here. Let's put it to her. Wait, come. Even he's scared of the cat. It's not going. Okay. 9V point cell, double A battery, or a triple A. Let's make it triple A. All these battery work in the same concept, right? They're just different. Now, why are we not always using the potato and lemon to charge our computers and stuff? Because it's messy, right? Remember, the step one itself is you squeezing the juices of it, which is not really hygienic, you can say. So the industrial batteries are much more cleaner. They are stronger, they're durable. They are not edible, sadly. So you can use these batteries, but in case you can try it with these potato and lemon. All right. So next time someone says science is boring, just tell them you can make electricity from a potato or a lemon. We are gonna conclude this session. I'm gonna show you what's the chemistry behind. So there is the chemical energy in your lemon and potato. It's actually changing into electrical energy, which is the reason why the whole LED is glowing up. And we learned how the different acidity levels and the electrolyte content influence your voltage, right? If you have high acidity level, then the voltage will be high. They are directly proportional. Whereas the longevity of the battery is inversely proportional to voltage. Inversely proportional in the sense, high voltage, low longevity. It's not going to last long. I gave you a very funny example of it, right? So, yeah, that's that. And you can light up LED. Not only LED, you can light up a lot of things. To be fair, you can use, let's say, a motor or a vibration motor connected to this, and it would still work, right? I want all of you guys to try these out. Um, I'm gonna give the link in the description for your LED zinc coin, like the copper coin and all those things. So you can check that out. Drop your voltage in the comments. Check how much voltage are you getting, and how in the real life also you can check it with a multimeter. So I want you to drop your voltages and how many lemons and potatoes you have used for your experiment, right? So like Zinc said, I'm out. I'm gonna say I am out. So that's all about it. And I want you to actually try powering your phone with a watermelon. It's super easy. It's not gonna be crazy. If your parents ask why are you doing this crazy stuff, just show them that it's charging and they're gonna be like, oh my God, raise them up. Until then, see ya.